Hello everyone, and welcome back to the Digital Twin Theory, a podcast about innovation in healthcare produced by the Virtual Physiological Human Institute. My name is Davide Montesarchio, and today we will talk about artificial intelligence. We will discover what is AI and its impact on healthcare. Our guest for today is Leonardo Castorina, PhD student in Biomedical AI at the University of Edinburgh, specialising in AI-driven protein design and immune system research. So, hi Leonardo, and thanks for joining us.
Hi, thank you for having me.
So, Leonardo, it's been some time that AI is really all over the place and everyone talks about it. But how can we really define artificial intelligence and how it really works?
Yeah, it's so true. Everything seems to have AI at the moment. Essentially, it's a pattern recognition tool. So given some data, this system is learning to identify some patterns. The easiest one to understand, I think, is the outlier detection. Say you're making pieces of paper and you expect them to be white. If you have a black spot somewhere, that's an outlier, something that's going wrong. And sort of the AI is there to pick up on these sort of outliers in the data. In a medical context, this is more interesting because you can pick up on anomalies which are not normally there. So something like a cancer in a patient. So this is why we're all quite excited about using AI in the medical context, because we can see some things that maybe the human eye cannot see.
And since when AI started to becoming helpful in healthcare? Is it something really recent, or it is something that started more back in the day but only now became, let's say, famous?
So yeah, AI is an umbrella term for many things. Some people call statistics AI. Some people call more complex models AI, so something like machine learning or deep learning. So yeah, it started out, I think in the 70s, 80s, but really it started to become a thing, especially in healthcare, in the 2000s when processing power started being more available in computers. So yeah, essentially, initially it was very rudimentary, something based on very simple types of data, something like how many days the patient has been sick, how likely it is that the patient needs to be transferred to the hospital. So very small things. But since the 2000s, we started getting different types of data, just images. And images are very, very cool because they are very, very easy to sort of process when you have good processing power. And I think since 2010 or around that date anyways, more image analysis tools have started to develop. And this is where the term deep learning started to become a thing, where you have more complex models that are essentially parsing these images. The main ones are neural networks, which are very useful in processing all of these images. And more recently, large language models like ChatGPT. These are also based on neural networks. So it's essentially just a very complex tool that can be adapted to many, many types of data.
You already made an example in the beginning, but how AI can help in healthcare? What are the different things where AI can bring an advantage?
So there are many things. The simplest example, continuing on with the example of the images, is, for example, retina scans. When you go to get your eyes checked, the doctors are essentially taking pictures of the back of your retina. And one of the applications of these images is, the doctor looks at these images and checks whether there's something wrong, whether to refer you to an eye surgeon for a surgery. Now, this process is actually, quite tedious, and you actually need specialized people to look at the retina. If you think about the world, there are countries where not always you can have specialized people to look at the images, but you do have the equipment. You just don't have the manpower to analyze it. So AI is sort of coming as a helpful tool now that can be easily deployed everywhere and can help you screen patients very, very early on. So, for example, if you only have one doctor in a city, the doctor will have to scan, literally lots of patients. So you want to prioritize patients that are more needing of a possible surgery. So it's a good way of pre-screening your population, for example. Other applications that are starting to emerge more recently with things like ChatGPT and language models in general is the fact that these tools can process language, and they process it quite well. And if you look at doctors, essentially a lot of the time is spent writing patient records. And this can be a very tedious task, and it's called the pajama time of doctors. Essentially, doctors right before going to bed have to type out notes of what happened during the day, anything that happened with the patients. And obviously, they're not paid for this. They're working outside their working hours, so it obviously contributes to burnout. So you can imagine a system where conversation between the doctor and the patient is automatically transcribed and summarized by these tools. The doctor can have a look at the summary and check whether it is accurate or not, so that the doctor can just focus, or can mainly focus, on the interaction with the patient, because the patient wants to have a human interaction. The patient doesn't want to have, on the other side, a doctor that's just writing and not interacting with them. So recently we're seeing it emerge as a possible tool to help doctors, especially when they're burnt out or there just aren't enough doctors.
In the bottom line, can we just affirm, is it correct to affirm that AI can help doctors saving time, reducing burnout, possibly also reducing errors, and especially improving the relationship between the doctor and his or her patients?
Yeah, I think this is the real opportunity for AI to really improve. And as you said, it's all about improving what the patient is getting. And we're at a point where we just don't have enough doctors, and we need to do something. Otherwise, we're just gonna end up with burnout doctors, which is what's really happening right now. So it really is about giving better care with the same resources that we have.
And going more on your field of research, AI-driven protein design and immune system research. So in this field, how AI can solve problems, for instance, in protein folding, which is a very long time issue, and what's the healthcare relevance of using AI for protein research?
Yeah, that's a great question. I mean, I'm always excited to talk about proteins. So proteins are essentially the architects of life on Earth. They do pretty much everything. So photosynthesis, DNA replication, energy production, they do everything. And proteins are composed of these building blocks called amino acids. You can think of them as Legos. DNA essentially encodes for proteins. So the proteins have these 3D structures, and these 3D structures are very, very precise, and they do things. They are molecular machines. So they do things because of the 3D shape. What we are interested in is creating 3D shapes that are useful. In the context of healthcare, for example, you have things like viruses. Now, the audience, I think, is familiar with COVID and the coronavirus. On the coronavirus, there are spike proteins, and your antibodies attached to then lead to an immune response. So you can even think of, for example, of a new virus that arises. And what we are interested in is, well, assume that we have the 3D shape of this new virus, of the spike protein, then we can think of something that's complementary to that shape that binds it. You can think of something like an antibody. Once we create that 3D shape, then we sort of need to produce it in nature. And so we need the exact recipe of these building blocks that are required to get that 3D shape, so then we can build these new antibodies. So my research is about how you go from that 3D shape into the building blocks. Protein folding is the exact inverse of this. So given this recipe of building blocks, what is the final 3D shape that we get? And so they go hand in hand, design and folding. Because once you design something, you then need to check that it folds the correct 3D shape. The reason why we're super excited about protein folding and AlphaFold more recently is that before AlphaFold, or before these models came about, biologists used to spend days, weeks, and even years collecting the 3D shape of the proteins, because it requires crystallization, and proteins don't really like to be crystallized. So we are now able to get the 3D shape of a protein very, very quickly just by giving it the sequence of the building blocks, amino acids, into these AI systems like AlphaFold. And yeah, so this speeds up a lot the design search. So we have lots of candidates that we think will fall to that shape. We give them to AlphaFold. AlphaFold says, okay, these are more likely to fold. And then we go into the lab already knowing that some of the candidates are more likely to fold into that 3D shape. So it's a good pre-screening tool and saves us a lot of wasted effort.
Awesome. And thinking more in the future, is there any problem or medical issues that you expect or you foresee that artificial intelligence will improve the research or the treatment?
Yeah, so I think the main things are something like antibiotic resistance and new viruses. And especially with COVID, we realized that we're really not ready. So a new virus can literally shut down the economy and society and really affect us, not just on a societal level, an economical level, but also on a human level. So it's very important that we tackle these issues. The problem is that the rate of evolution of bacteria, of antimicrobial resistance and new viruses is very, very quick. So we need a quick tool to counter that. And the only way we can do this is by extending AI to these applications. So I think the main things that are going to be useful is especially in healthcare and especially in targeting bacteria and viruses, but also things like cancer. And actually a lot of the drugs that are used in the medical context are also proteins. So proteins are literally everywhere essentially, and we need to find a way to design these proteins in a way that is useful. And the thing is, it's a very complex problem because there are 20 building blocks. And each of these 20 building blocks is used to make a protein. Now, a protein can be of any arbitrary length, but it's usually about 200 amino acids long. Now, the amount of combinations that you can do with 200 amino acid long and 20 amino acids for each position is so large that there aren't enough atoms in the universe to look at all of the possible combinations. So to try all of the possible combinations, and that's just for 200 amino acid protein. And you can think of like any sort of arbitrary length. Some of them are 100 amino acids, some of them are 1000 amino acids. So there's a lot that can be designed. And we really need a way to sample from this possible design space into something that's useful for us. And I'm very, very sure that among these many possible proteins that are the future cure for cancer or the future cure for specific viruses, we just need tools to explore this large space. And AI, I think, is a very great tool to look into it.
Great. I guess that our time is gone for today for this very rich, inspiring episode. Thank you again to Leonardo Castorina.
Thank you so much.
And thanks to our listeners. We just started this journey and a lot of you have been listening to the first 2 episodes. We will be back next month with the 3rd episode of the Digital Twin Theory about in silico trials. In the meantime, keep listening to our episodes and follow the VPH Institute on LinkedIn, X, Facebook, and Instagram. Have a good one.